started talking this conversation about systems principles. And as you guys are learning fairly quickly, at the end of week 5, we have this all of the above sort of approach this semester. A little bit of playing with balloons and straws, a little bit of playing with electronics and actual chips and resistors, a little bit of talking about chemistry and semiconductors, and a little bit talking about this idea of systems thinking and the business side of things. It's definitely a hodgepodge. It's definitely sort of a stew of different things, but I know you guys are cool with this. You realize there's a central theme. Okay? Everything is connected, and we're looking at different systems. We're looking at different systems as they are created and used and explored at different levels of sort of why are they useful. So we've talked so far about electronics systems, and we've been working with electronics systems in labs. And here, when we talk about this stuff on the Prezi, we usually talk about business systems, people working together as a team, or people working together as a company. And then fairly soon, after our first midterm, which is a week from this Monday, and we'll have a lot more information on that, so you guys are ready to take that during lab the week before spring break. Soon after that exam, we're going to start a little bit before spring break. We'll take a break. We'll come back and finish this up. We're going to be in the lab. We're going to be talking specifically about software systems. How do we actually create things inside software, and how do we get software components to work together properly, just like we've been talking about how do we get electronic components work together properly. And again, with the Prezi, we'll be talking about how do we get people to work together properly. So the reason I started here inside Canvas was to let you know where this is, in case you want to go back and grab it. Good morning, Brianna. Everybody, okay? So we are talking about this Prezi. We got a little bit further through this Prezi here. This is Prezi number 2, or chapter number 2 from this text. I'm going to show where you guys can find it. It's on that home page inside here. It goes over to Prezi. It's shared with you, of course, and you can watch it if you'd like. What I want to do is I want to open this thing up here, and I believe I have my thing working. I do. Fantastic. So we had talked briefly about this on Wednesday. We were talking about this idea that our author is talking about, and what, quite honestly, what ISBT has been based upon over the past decade and a half, is that let's talk about all kinds of systems. Systems is a very overused word. Yeah, there's electronic systems, there's computer systems, there's systems. We're specifically talking about business systems and things like LaSalle. LaSalle is a business. LaSalle is an organization of humans. And we're using these very, very multi-syllable MBA, Wharton School of Business level speak, okay? So yeah, so purposeful, multi-minded system. It sounds like gobbledygook, because it probably is, unless you're talking to a fellow systems person, and they go, oh, I know what you're talking about. I know where you're at. Again, 5 different dimensions, if you will, but nothing magical about 5. It's just how the author has put them out together. We were talking about this idea of systems that are useful, and especially systems that are purposeful and multi-minded. They're typically open. They're not closed. We talked about systems being open and closed. The closed system doesn't do anything. It just hangs there. A closed system could be like the amplifier we were talking about. It was open to energy and voltage, but it wasn't open to new ideas or how to do things. It just does what it's supposed to do. It's done. It's a mechanical system. When we're talking about people, they're definitely open. At least they should be open. If you're working with somebody who's not open to new ideas, maybe the new ideas are useful and would help a lot of people and would really save the day if we just did things differently. Sometimes we'll even use the term closed to be a negative. It's, you can see somebody in a movie, or maybe even yourself, you're so closed-minded. And we use closed-mindedness as being a negative. Sometimes it's okay to be closed to new ideas if the new ideas are goofy or haven't been tested yet. But we're specifically talking about being open to new ideas, especially open to new technology and new innovations. We talked about other companies that were not open to new innovations, and purposefulness, instead of every component of a people system doing something because they've been told, we have all kinds of sort of negative words. We talk about totalitarian systems. We talk about monarchies. We probably study all these different forms of government and forms of living together as humans. We like to think that in our capitalist society here in the United States, that we can provide opportunities to people to be in a system, and hopefully they have meaning, they have purpose. Okay? Usually humans are happier, and they've done studies, if what they're doing throughout their day, they feel like they have purpose. I'm doing this for a reason, not just going to work and being robot number 47 and pushing this button. Maybe the purpose you're doing that is to get money so you can go be a painter in the evening. That's fantastic, but if this is all you got, it's not very fun. The happiness goes away. People are much more happy when they have a purpose. We started talking about this idea of multi-dimensionality, and we're going to skip ahead to that, but one of the things I drew on the board very quickly was this number line of there's a value over there, there's a value over there, and usually inside physics, for those of you who were with us last fall, where we were doing all those plots with physics, we would say this is the positive side, and this is the negative side. And we know, because we're scientists, we know that positive and negative just happens to be opposite positions or opposite directions on the number line. Doesn't necessarily mean that positive is good and negative is bad. Doesn't have to be a good versus bad thing. But a lot of folks, a lot of people in systems who are not open to new ideas or are not thinking about the purpose of what they're doing and they didn't do what they're supposed to do, sometimes they like to think very single-dimensionally or one-dimensionally or linearly. And we specifically talked about artistic and science. Scientific. Okay? And this is a topic that I often speak on, and that is why in the world would LaSalle and other places put the arts and the sciences together? Why are we in the School of Arts and Sciences? It sounds like you would fight like cats and dogs. Obviously, the artists are way over here, and they're the positive people, and the scientists, they're on the negative side. So we put a negative. Scientists are all about getting the right answer and calculating a lot of math and blah, 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 blah. Artists are happy, and they're free, and they're singing and performing. That's one way to look at it, but it's very single dimension, meaning that artists and scientists are on opposite sides of the spectrum of possibilities. That's one way to view the situation if you are stuck in this, I get to use our vocabulary word, if you're stuck in this paradigm, the paradigm of looking at one or the other. Well, today I think I'll be artistic. I'll leave my science stuff at home. Oh, today I have science class. Art isn't until Monday. I get to be scientific today. Okay? You can think that way, but you don't need to give one up to be the other. The School of Arts and Sciences involves both. So the way to do that, how in the world can you involve both? And this is a paradigm-shifting thought. This is a mind-blown thought. You take this line over here, and instead of having it go negative, you make it go up. Okay? We're going to go ahead and bend this line, or break this line, or draw this line. Here's artistic we had before. But now we're going to make it vertical. All I do is take that line and snap it in half and move it up. So now we have science still here. This is still very high science. This is still very high artistic. But what we've done now is they both have positive directions. Now, there is no positive and negative. Negative's not the wrong direction, or you're losing ground, or it's bad. They both have positives. This just means more science in the positive direction and more art in the positive direction. Zero's not a bad word, it just means empty. Nothing's there. Okay? So what we have here is we started talking about this on Wednesday. And here's this picture of this bent axis. But the author inside of our book went ahead and took this quadrant and made even more quadrants. And said, over here, specifically, is very much or a lot of art and not much science. Over here is a lot of science, but not much art. Here is not much science, not much art, and of course the opposite corner over here is high on both. So this is a paradigm shifting way to think. We've shifted the paradigm from thinking one or the other, and we're changing from or to and. So now we can have both. We can have science and art at the same time. I don't know why I'm sensitive to that black mark. Hope it wasn't me. I don't like to put things on. Fantastic. The author also goes ahead and says, well, how would you go about defining an artist? Of course, I did the Hollywood caricature of the artist that is expressive and does a lot of things with the performing arts and is very creative. And the scientist is in the lab and kind of not very fun and Big Bang Theory and kind of geeky. That's sort of the way Hollywood thinks it. Good morning, sir.
No.
This is how our author suggests it. The author suggests that artists, or people who think artistically, or if you're using the art side of your brain, another way to think of it differently, artistic and scientific, again, we both have both halves of our brain, so they're both working at the same time. And that an artistic ability is the ability to find differences among objects which seem to be similar. Okay? So, how many people in here have an art class, or have had an art class? What type of art history or art? Yeah, so they show you all these paintings, and they're probably, I'm guessing, they were all painted at the same period, and the instructor, or as a class, not only were you supposed to identify maybe when they were painted or who they were painted by, but maybe you look at the little differences in between the stuff. And that's not, you took the class, I didn't. But when I took art history, it was, look at these lines over here, and then after a while, the artists realized that this new paint was available, so now this new color is available over here, or they decided to paint on layers. They put the darker colors first, lighter colors there. Anybody know who Bob Ross is? The guy who paints the happy little trees? He was really, really big. He has a method where he would paint a scene, but he wouldn't let the first paint dry and then come back and then paint. He would always paint wet. So he'd sit down for half an hour. He'd paint an entire painting in like a half an hour. He'd paint wet on wet. It was a new technique. But that allowed the artists to think about things a little bit differently. And what's cool about that is, if you look here, let's just stay down here and look at high artistic ability all by itself. They're usually the folks that recognize that we have a problem, that somebody has a problem. Our business has a problem, LaSalle has a problem, where I work has a problem, my family has a problem, I have a problem. Usually, what that means is you're able to see what is different between things were working really, really well, and now things aren't working as well as they were before. What changed? What's different? Okay? That is why we value people who can think artistically. You don't have to be a trained artist. You don't have to be a ballet dancer. You don't have to be a world-famous sculptor to be able to find differences, but you can think artistically. Everyone's artistic. You can think artistically, and one of the things you can do is you can use that skill to look at a situation, compare it to a different situation, and then find out where the differences are. If you have a great ability to find the differences between, wow, we had a great time last Friday, and this Friday, things kind of suck. If you can tell the difference, then there's a chance that you can work on why things are bad. Now, you can make things better. Before you can solve a problem, I'm not suggesting that science is not before or after, but before you can solve a problem, you have to know what the problem is. Otherwise, you're going to solve the wrong problem. So you need to move over to, if there's a side, you have to use that part of your brain that thinks artistically and is able to look at these two things and find out which is different. Do they still play reruns of Sesame Street on TV? One of these things is not like the other? Do you guys, yeah, that's been around for years. I remember that. It would show you 3 items, and then one of them would be, to an adult, would be obviously different. And you'd say, well, do we still go to dentist's office and read Highlights magazine? No. There used to be a little magazine that was on the. It was like a picture of usually it was a non-colored picture. It wasn't a word find, it was a difference find. They'd show you a picture and they say, can you find those 5 things that have changed between these 2 pictures? Okay, it's actually a skill that they teach young children. Can you find those things that are different? And if you happen to be a mid-career professional who is able to walk into a company and see how things are going now and how things were going before, and they're like, what the hell's wrong? You get paid a lot of money as a consultant. That's what you do. You're able to tell them, hey, here's your problem. Once you have identified the problem, then it happens to be useful to use this side of your thinking, or this dimension of your thinking, science. The ability to find similarities among objects which seem to be different. It's not the opposite skill, it's the complementary skill. Okay? Find differences among things that appear to be similar. I don't see a problem here. It's exactly the way it was yesterday. Oh, there's a crack in the wall. Oh, that could be bad. Oh, look, the foundation's crumbling. We should probably get out of the building. Okay? That's finding differences. Science is the complementary, the ability to find similarities among objects or things or situations which appear to be different. Usually that involves, hey, we discovered that we have a problem and we'd like to fix it. Let's go to so-and-so who's going to be our problem fixer. Using their scientific ability, they can say, oh, thank you for telling me what your problem is. This looks very similar to a problem that this company had 5 years ago. And they tried different ways to fix it, but this worked best for them. Why don't we try that first? Okay? Maybe your situation, your problem, is similar to a problem that somebody else or some other organization had, and this is how they solved it. It may not be the exact solution for you guys, but maybe that's a good place to start. Okay? So this ability of finding problems and then solving them go hand in hand. And typically, if you have a team, you'd like to have some members of your team that are very strong at defining and finding the problem. Some members of the team that are very, very strong at solving the problem. However, more and more in 2016, our hope is that you can hire team members or invite team members that can do both and can do both very, very well and do it inside their own head. So it's great if you can be a problem formulator and a problem solver, not at the same time. You may literally say to yourself or say to your partners, well, let me have a look at it. Let me see if I can see the problem. I'm going to put my problem solving, I'm going to put my problem formulating hat on. I'm going to use that area for now. So you can think about switching gears or the same gears. If it's possible that the same person or the same team can do both, then we call those folks innovators. Because what they're able to do is they're able to spot a problem and fix it while other folks they don't have both sides of the peanut butter and the jelly, or the peanut butter and the chocolate. You need to run away, right? Thank you. Down here, low artistic ability, low problem solving. I don't spot a problem, and I'm not spending time to fix it. I'm a doer. Do we like doers? Or are the doers the stupid people? No? You want to defend the doers?
I mean, maybe they're just like, they're hands-on, I guess. Like, they just see it, they
stupid people, and I like to use the word stupid a lot. Imitators and doers. If you were to plot different careers, this is where you would find doctors and lawyers. Okay? Do we consider doctors and lawyers stupid? No, probably not. This is doctors and lawyers. Doctors and lawyers don't do research. And doctors and lawyers don't perform. What do doctors and lawyers do? Remember the word we used for? What do they do when lawyers do something with law and doctors do something with medicine? They practice, right? They practice medicine and they practice law. Okay? Even though they've been doing it for a while, how many years have you been practicing medicine? How long have you been practicing law? Thank you so much. I'll see you online. We'll see you on Monday. Have a great weekend.
You too.
Being a doer, not spotting a problem and not solving a problem, has nothing whatsoever with stupidity. It's nothing. It's not negative. Again, this negative idea goes back to this paradigm of thinking. Either you're awesome or you're not. Either you're an artist or you're not. In this case, maybe we can switch and say scientific is positive. It's not the case. And we're not saying that positive is awesome and low is awesome. What typically happens here with the imitators and the doers, and again, individual people have the capacity and the capability to be any quadrant, depending on what it calls for. The imitation of the doers, professional lawyers, professional physicians and doctors, professional athletes. Do athletes practice what they do? Well, hell yeah. You're playing first base. It's the World Series. The winning run of the opposing team is on third. Okay? Here comes the ball. What do you do as the first baseman? Okay? Right. The hope is that you don't think about it. The hope is that you just react and you do make the play. Okay? Why would you throw it to home? He's out. Why would you catch the ball, batter's out, throw it to home, out? Why would you do that without thinking? How could you possibly do that without thinking? Habit, training. Why? Because the first baseman practiced that how many hundreds of times? I think there's some self-help books that say in order to do anything without thinking, I don't know where they got this number, you need to do something 10,000 times.
21 days.
I'm sorry? 21 days to break a habit, okay? But to actually learn an item or learn, like, I'm sitting here talking and being goofy, and I'm walking around. Thankfully, I haven't fallen over yet today. I'll probably fall over yet today. But when I first learned how to walk, it was not pretty. I was falling all over the place. Now, have I taken 10,000 steps in my life? My watch tells me I do a pretty good job of taking a bunch of steps every day. Okay? No one is suggesting that 10,000 is the real number. It's just a lot. Okay? And you have to practice it. There are situations when, here's our guy, we love these pictures. Here's an axis, here's X or Y. For those of you who were with us in physics last semester, we talked about X position, we talked about Y position, we talked about velocity, we talked about acceleration. What's the other thing that we usually put on the horizontal axis inside physics?
Time, thank you.
The reason why, the reason why doing something and doing it well, often we just don't have time to screw around. Okay? If you're at first base and here comes the ball, I don't have time to think about it. What should I do? God forbid, I don't do my walking very well. I fall down and I hit my arm on the way down, and now I have a compound fracture. It's just sticking. It's gross as hell. Please call the squad. Please get me to the emergency room. And I get there, and the doctor says, wow, never saw a broken bone before. probably go over to the library, maybe back over to little Salle and look up how to fix a bone. No, please fix it now. Okay. Well, let's experiment. Let's see if touching it, wow, that hurt. Yeah, that's bad. Don't touch there. That's bad. So there's times when experimenting and learning and spotting the problem and then wrong. We don't just fix it. Okay. So one of the reasons why, if you are not an ISBT major and you are a pre-med major or a pre-law major, one of the things that the pre-med and the pre-law classes ask you to do is memorize a shit ton of stuff. You're not allowed to use the web during your test. You can't use your phone. You can't talk to everybody else. Come in, you got 50 minutes to take the exam. I hope you memorize the book because it's on the exam. Go. Why in the world would that be useful to somebody who's pre-med or pre-law? Memorizing stuff and then during the exam just go ahead and do it. Fantastic. They're not being mean. It's not the wrong way to learn. It's not goofy. It's not like, oh, damn pre-med classes, I hate them. All I do is memorize shit. Because that's what you do as a physician, okay? What's wrong with this person? Appendix. Great. We're taking the appendix out. What's wrong with this person? Oh, heart attack. Great. We're treating the heart attack, okay? They don't have time to look it up, okay? I think it's been a while since I pushed this button over here. The reason why I have this little tiny item up here is I love our logo, of course. I put ISBT up here, okay? If something is wrong with your product and people aren't buying your gadget anymore, or your employees aren't happy anymore and maybe we should redesign how things go, we have a little bit of time to figure it out. It's not instantaneous. People aren't bleeding, and we're not, when I didn't do the example of the lawyer. I don't know how many people watch court dramas anymore on TV, but in the afternoon, there's the judge, there's the jury. You have 10 minutes to make your closing arguments. You don't have time to go do the research. Hopefully you did the research and you made it brief, okay? But when you stand up and say, ladies and gentlemen of the jury, here's my argument, you gotta roll. You don't, it's not like, well, let's go do a Google search first, then we'll come back, okay? That's different in ISBT. In ISBT, when we're trying to find the problem that folks aren't sure what the problem is, we have time to sort of snoop around and do an investigation and talk to folks and collaborate and look to the web and back and forth. When it comes to, once we figure out what the problem is, how in the heck are we going to stop these phone screens from cracking? We have a little bit more time to do the research. In fact, we have so much time to do research that we have time to go back and search a second time. That's why it's called research. If you only have time to search once, then you just search something. How'd you get this answer? I searched it. Okay? But if you're a scientist, you research stuff. You go back and you do it again because you have the time to solve it. Some problems we haven't solved yet. Why don't we, I apologize if someone has cancer. Why don't we just cure cancer? Damn it. Why don't we just cure the common cold? Because we're trying like hell to do that. We don't know how yet. It's a very large problem. It's taking a lot of time. People are not lazy. They're not kicking back. They're not saying, well, if we only try harder. They are trying harder. And they're curing a lot of conditions along the way. And do people hold hope that someday when you walk in and say, I'm sorry, we have to treat your cancer. Can we fix it? I'm pretty sure the answer will be yes, we can. We can make it go away. It's just not there yet. But I'm not suggesting we have the luxury of time, but it's taking some time. So in this class, in an ISBT class or any of our other classes, consult the internet. Please use your phone. Please talk to each other to solve the problem. We're training you. We're getting used to. We're giving you guys experience for a different way of working. Okay, we're not pre-med. We're not pre-law. Nothing wrong with pre-med or pre-law. We're not that. That's not the environment we're going to release you into. we're going to release you into an environment where they're asking you to innovate. We need a new project. We really are trying to solve or cure a certain flavor of cancer. What do you think we should do? How should we do this? Okay. So all of these things are important, and that's what we think that's our target at least. We'd like if individual ISBT majors can display artistic abilities and work on their artistic abilities, and at the same time display scientific abilities and work on their science abilities. We prize both of them. And for that reason, that's exactly why ISBT is in the School of Arts and Sciences.
I have a question. So a person who is doing technology transfer, is
Yes.
that person a doer or a innovative person?
I would suggest they're an innovative person. And whenever you're inventing something,
Right.
so technology, they may not have invented the exact technology,
Right.
but having it be used by many people, that's a new thing.
Right, but they're just basically memorizing how the process went, and then they're just representing it to a larger audience. So they're basically just doing what a doctor does.
We can agree to disagree. You can look at it from different perspectives. I'm going to suggest that technology transfer takes time, and I guess it's my personal test. I've not written a textbook, so I'm not saying it's right or wrong. My personal test is what you or your team doing going to take some time to do, then I consider it an innovative process. Not that getting your spleen out doesn't take 4 hours, but again, the development of spleen surgery took some time, but actually doing it, that's a little bit faster. So at least I'm just trying to explain how I look at it. I don't see a right or a wrong bin.
It's both.
It's both. Damn it, exactly right. Depends on how you go. So that's where we're at. Before we go on to this emergent property, just to say a few words. Is everybody aware of the prioritization process that LaSalle is going through right now? You guys heard of this? The strategic prioritization process. LaSalle is taking some time, to find out how they could better serve you guys and better serve students in the future. There's lots of changes in higher education. My generation, the 50-year-olds of the world, the age of your mom and dad, 45, 50, we didn't have enough kids. We definitely didn't have enough kids as much as ours. So the actual number of students is lower than it was before. So the question is, what can a university do to be innovative and present majors that are important to folks and make sure everything is working well? We're currently going through that process. Right now we're going through the formulation process. We're going through the artistic process, and we're looking to see how each of our majors is, how can I say the word, different. How each of our majors is special. What makes each of our majors special. And if we get an inventory of how each of our majors is special, then we can go back into problem solving mode, and we can see how best to organize them and bundle them and then present them to high school students and get them to convince them to come to LaSalle. So we're doing that right now. We're actually doing it this spring. So while we're talking about some businesses do this in order to reinvent themselves, LaSalle's going through that right now. So I don't know if it was prevalent. You guys heard it on campus. There's a bunch of talk going around that we're looking at every major, and then the solution is to find out which ones aren't making any money and which ones don't have enough students, and then we're going to cut them and make them go away. That's not true. It wouldn't be cool. In fact, it's not even close to what we're doing. LaSalle is redesigning how we do what we do in order to get better, because we want to avoid problems in the future. There are other universities that are having problems that are really, really great, like not enough money to, pay their employees. That's not LaSalle. We're not there. But we don't want to be that. So I think we're being very smart to stuff that LaSalle's doing now is the same stuff that the Continental Can Company should have done when they invented the damn two-piece can. Because 3 years later, they were gone. But no matter where you're at business-wise, wherever you guys end up eventually getting hiring, you're going to go through this process all the time to make your company as good as it can. And then the actual process itself, it involves a lot of uncertainty. Some people get a little goofy and say, well, I don't know how it's going to turn out. But that's what we're doing right now. So if you hear stuff running around campus, apply it to what we're talking about inside class. We're definitely not looking to shed majors, and we wouldn't do that. We're not going to ask anybody to lose their major, but we are finding out how the majors can be readjusted. Our next property, emergent property. I think we have time to get through this past fact. I mentioned before that a system view sort of looks at the entire system, all aspects of it, whereas a analytical view takes it apart and looks at the pieces. When you find a car that you've never seen before, hey, look at this nice antique 1947 whatever, let's see how it works. Rather than starting it up, you just start disassembling the engine. And that's okay. That's one way to figure out how it worked. I've never seen this. Oh, look, I found this World War II plane that I didn't even know Germany made. Let's go ahead and take it apart. Okay, and that's fine. But then once you take it apart, you can't really hear how it sounded. You can't measure how well it performed. If it was a car, how quick was it? How fast was it? Those things of how fast is the car, how quiet was the airplane, how quickly could it turn in a battle, those are emergent properties. Those are properties that you can measure only when the system is working. When it comes to athletes, talking about teams, creating a winning team, whether it's a winning basketball team or a winning bowling team, a winning checkers team, a winning any team, you can't measure how winning the team is until you put the team together and you practice and then you play. You can't just look at the individual players. Okay? Every week on your fantasy team, the individual players have to go out and play, and then you can go back and figure out how well they do. So that's an emergent property. Emergent property is a property that we can only measure once the system is functioning. It has to be running in order to find out how well it's doing. So it turns out that emergency properties, again, they're spontaneous. They're things that you measure while things are working, while the process is doing what it does. Things like, you could probably use this for your philosophy class. For next week's paper, I want you to write a 5-page paper defining love. What the hell's love? It's an emergent property, okay? I love The Walking Dead. Actually, I don't. I've never seen it, but maybe you have. I love The Walking Dead. If you've never seen The Walking Dead, which I haven't, and you haven't watched all of it, you haven't binged on it, then it's difficult to love something unless you actually do it, okay? So in this case, if you stopped watching The Walking Dead, or they stopped making more of them, then your love of it would probably go away, okay? So this love idea is something that you're doing now. And again, these other things like happiness and success, they have to be reproduced all of the time. It's something that you get when the system is working, when the system is running. Okay? The reason I brought this video along is sometimes me just jumping up and down and flapping my arms is humorous but not useful. I wanted to bring along some pretty famous names of folks who are describing these things. These are faculty members and professors and business professionals that are talking about different concepts here. I think we have enough time to listen to this guy, see what he has to say about emergent properties. Let's see if I can get this guy to work. Great, it worked. So this is Ian Somerville. I'm going to make sure this works.
And in this video, I'm going to be talking about one of the most important characteristics of socio-technical systems, the notion of emergence or emergent properties.
I love his accent.
There are 3 types of characteristics of socio-technical systems that are particularly important. One of these is this notion of emergent properties, which are properties of a system that only become apparent when we put the system together. Another is non-determinism, which means that the system will not always react in the same way when we present it with the same input. And the third is the notion of subjective behaviour, where the behaviour of the system, or how effective the system is in supporting organisational and personal goals or objectives, depends on the interpretation of the user or the stakeholder in the system. I'll be talking about non-determinism and subjective behaviour in a separate video. Here I'm going to focus on emergence. There's a well-known saying that the whole is more than the sum of its parts, and this applies to systems in particular, that there are emergent properties in a system, and these only become apparent when we assemble the system from its components. We can't deduce the emergent property by analysing the components or these particular properties within the components and then adding them, say. The emergent property is something different from that. All systems have got lots of emergent properties. This is an example of an aircraft, and you can see some of the emergent properties of that aircraft, which only appear when the aircraft is assembled. Why do we get these emergent properties? Well, the emergent properties arise because of the relationships between the components in the system, so we can only measure and assess those emergent properties when these relationships have been created, that is, when the components have been integrated to create the system. And there are two types of emergent property. There's the notion of functional properties, which by and large are what we're trying to achieve when we are creating a system. So if we take an example of a bicycle, if we have a box of bits of a bicycle, they don't do anything. But when we assemble these in the right relationships, we create a transportation device. So a functional emergent property is something that the system does, and usually what we're trying to do as part of the design process. Non-functional emergent properties relate to the behaviour of the system rather than its functionality. And the abilities, the dependabilities, the security, the safety, usability, reliability, and so on, are all non-functional emergent properties. Non-functional emergent properties are often particularly important for critical systems because if a system does not reach the right level of reliability, say, then it may be completely useless. It may not be able to be deployed and used as intended, even if it is functionally correct. Much of our development processes are geared towards ensuring that we can achieve the appropriate level of non-functional emergent property. Here's an example of non-functional properties. The volume of a system depends on how we assemble it. We can assemble it in different ways and it'll take up a different amount of space. The repairability of the system is how easy it is to repair a system when things go wrong, and that depends on accessibility of components. How easy is it to find a bit of software sometimes? Sometimes we have great difficulty in actually locating where the software is in our computer. It depends on whether or not we have the right tools to carry out the repair. The reliability is an emergent property that I'll come on to and look at it in a wee bit more detail shortly. And the security of a system is a complex emergent property. It's very hard to assess and measure security because the attacks that might be made on the system are something which we haven't thought of or which haven't even been devised yet by an attacker. Let's look at reliability as an emergent property. We know that reliability depends on the interrelationships between components, and when we have unforeseen or unanticipated relationships, we may get a system failure. Because it's practically impossible to anticipate or understand all potential component relationships in a complex system, we can never be sure that systems will not fail. We must always work on the assumption that there is some kind of failure mode remaining in the system. In a complex socio-technical system, there are three principal influences on the reliability: the hardware, the software, and the people using the system. When it comes to hardware reliability, it's about the probability of a component failure and the time it takes to repair that component and get the system back into operation. So availability as well as reliability are important. For software failure, it's again the probability that a component, when presented with a correct input, will produce an incorrect output. But it's different. Software is different from hardware reliability in a number of important ways. First of all, we know that hardware will always fail. Because of the laws of physics, hardware will eventually wear out. That's not true for software. Software does not suffer from normal wear and tear. For software, the other important difference is that the failures are often transient. If we reset the system in some way, either by rebooting it or simply by overwriting an incorrect value in the state, we can repair the problem. So it's often much easier to repair software than it is to repair hardware. And operator reliability. How likely is it that the operator of a system will make some kind of error? And how serious will that error be? This is an example of a very serious operator error where a train driver in Spain took a curve at a much higher speed than he should have done and caused an extremely serious train crash. So where does the emergence come from? The emergence comes from the fact that these different influences on reliability interact. So if we have a hardware failure, this may cause the software to behave in an unexpected way. This can be misinterpreted by the operator, who takes the wrong actions. These are interpreted by the software, and sometimes these could actually make the hardware problem worse.
Okay, so there's another bit of this guy. I just wanted you to hear it from somebody else. We'll be talking more about this. All of the things he mentioned, hardware errors, software errors, user errors, we'll probably be using the phone as an example of that. Has everybody heard the rumors that the next iPhone will remove the headphone jack? What?
No, why though?
Why? They first of all, they're talking about Bluetooth, but secondly, they can't make it any thinner because the hardware jack is limiting it. So they've already went to USB-C, and then the hardware jack will allow them to make their phone even thinner. But also, a thinner phone means that the screen's easier to crack. So they had to make the glass stronger too, or bend. Yeah, exactly. So again, they come with it. Oh, it's Apple. Yeah, it'll be $1,000. I'm sorry.
It's gonna be sold separately.